Sir, good afternoon, sir. Good afternoon, students.
So looks like only two people are going to be there today. We can get started if you are ready, ma'am.
Okay, sir. Just 1 minute. I'll start. Okay, so students, so today we are going to discuss with the current electricity topic. So let us go with the questions directly. So without wasting the time. So current electricity here in this chapter, the resistors in series, resistance in parallel, that derivation part is deleted, but some application based questions will come from that part in the CET or in the JEE, any exams you can expect that. Okay, so let us start with the question. Here you can see the first question. The current density varies with radial distance r as J is equal to AR square. In a cylindrical wire of radius r, the current passing through the wire between radial distance r by 3 and r by 2 is. So here, see the question, what they are saying here. The question is based on the concept of current density. As we know that the current density is equal to current per unit area. So current per unit area is called as what? That is the current density. Here for current density, they have given one equation, that is J is equal to AR square. So in the question, it is specified that the current density varies with radial distance as J is equal to AR square. Means here one equation they have given like this, the current density is varying, okay, in a cylindrical wire of radius r. So here you need to imagine that is one cylindrical wire is there whose radius is how much, whose radius is r here. So here in this cylindrical wire, the current density is varying with the equation of J is equal to AR square, where the small r is the radial distance. Small r is the radial distance. Capital R is the radius of the wire. Okay, so this is the first part of the question. In the second part, what they are saying, see, the current passing through the wire between. So here we need to calculate the value of the current, right? So what in question, we need to calculate the value of the current when the distance is varying between r by 3 and r by 2. So like this, the question is given here. The current density equation they have given, with that you need to calculate the value of the current, and what hint they have given in the question, that is the current is changing with the radial distance of r by 3 and r by 2. Okay, hope so the question is clear to you. So let us see how to simplify this. So whenever you have equation type question, either you need to differentiate that or you need to integrate that. Okay, so maximum times such type of questions we can solve it by either integration or by the differentiation method. Okay, so here you can see the current density, the equation is given as in the question, that is J is equal to, it is AR square. Okay, then next here, the current, as we know that the basic equation for the current density is what? Current density is equal to current per unit area. It is current per unit area. So therefore, current is equal to what we can write it? Current is equal to, we can write it as J into A. I is equal to J into A. But here, what they have specified, the current is changing between the radius of, that is r by 2 to r by 3. So whatever this value is given, this value you need to consider it as the limit range. Okay. So now here we need to consider the area, we need to take it as J into dA, and this is varying, this current density is varying in the distance of r by 3, r by 2 to r by 3. So that is I is equal to, so I is equal to, it is J into dA, and the radius is, or the range is from r by 3 to r by 2. Okay, so here now according to equation 1, so this is according to equation 1, J value is given. So according to equation 1, J is given in the question. So what they have given for the J here, J is given as See, substitute the value of J from equation 1, that is AR square into dA. dA is the area. Okay, so here you can see here side it is written where dA is given as for the cylinder. So for the cylinder, we take it as 2 pi RL. So here instead of that is L, we are considering that is with respect to radius small r, it is taken as dr. Okay, so therefore dA is equal to, we are taking it as 2 pi r into dr, which is equal to current I. Yes, up to this, any doubt is there up to this step? Okay, so first the equation what they have given in the question. Second step, the current density is equal to current per unit area. Later we have modified the equation as current density into area. Next, integrating the equation. Next, substituting dA as 2 pi r into dr, and J is equal to AR square, which is given in the question. So after this, very simple, just you need to integrate this equation, r by 3 to r by 2. Okay, so here, so all the steps are there. Yes. So here we have I is equal to AR square into the bracket 2 pi r into dr, and here the integration range is r by 3 to r by 2. So which is equal to, so what is constant here? You can see 2 is constant, pi is constant, a is constant. Okay, so whenever you are doing integration or differentiation, the constant terms are kept out. So 2 pi a, keep it out. After that, what is remaining? So inside the integration sign we have, so r square is there, r is there. So r square into r will be, it will be r cube into dr. Remaining things are constant, so it is taken out. And here it is r by 3 and this is r by 2. So which is equal to, so keep this 2 pi a as it is. Now integrating this equation. So I don't know how much you know about the integration. So just I'll tell the formula. So general formula in integration for the integration of dx raised to n with respect to dx is, okay, so ನೀವು ಯಾವ ತರ a plus b whole square like that formulas ಕಲಿತೀರಾ, same way in integration differentiation we have the formula list. So in maths we will study that, ನಾನೇನು ಅದನ್ನ detail ಆಗಿ ತಗೊಳ್ಳಲ್ಲ. Which formula is helping me here? Only that formula I am telling you. So here we have x to the power n into dx is equal to, the formula is x raised to n plus 1 upon n plus 1. So in the question, so question in the question we have r cube, in the question we have r cube with respect to dr, and here we are integrating that. Again limit range ide, leave that, which is equal to. So now in place of x we have r, in place of n we have 3. So therefore it is 3 plus 1. So 3 plus 1 will be 4 upon 4. Yes. So integration is clear. Simplification.
Yes, ma'am.
Okay, so after integration whatever this sign is there, okay, so iden sign irutte matte dr, this will go. Okay, so according to integration formula apply madidmele just ಏನು ಬಂದಿರುತ್ತೆ ಅದನ್ನ ಮಾತ್ರ ಬರಿತೀವಿ. So here we have, this is r to the power 4 upon 4, and here now integration sign will go. Iden range ide, here you need to write the top at the bottom. So this is r by 3 and this is r by 2. So which is equal to, so this is 2 pi a, 4 also you take it out now because 4 is not a variable, it is constant. Now what you are going to do? Now upper limit minus lower limit. So in r by 2 ide, that is called as the upper limit. It is called as upper limit, and this is called as the lower limit. So the method is what? In the limits you will study this one, upper limit minus lower limit. L substitute madbekandre, which is variable, there you have to substitute. Here r is our variable, so you can substitute there. So in place of small r, take the upper limit first. Upper limit is r by 2 and it is r to the power 4. So therefore make it as r raised to 4. Minus, now in place of small r, substitute the lower limit. So the lower limit is r by 3, its whole to the power of 4. Now this you can simplify. So now this is equal to, so that is 2 pi a divided by 4. And here r raised to 4 you can see. So this is also r raised to 4. This is also r raised to 4. That will be a common term. You can take it out. So inside the bracket we have 1 divided by. So 2 to the power 4 will be how much?
16.
16. Yes. So this is 1 by 16 minus 1 divided by 3 to 4 will be 27 3 is 81.
81. 81.
81, no?
Yes, ma'am.
3 into 3 into 3 into 3. Yes, correct. So if you simplify this one, you can take the LCM and do the simplification. Here the answer, the final answer will be 65 pi a rs to 4 upon 2592. If you want, you can just cross multiply that one. So cross multiply ಮಾಡಿ ನೀವು ಬೇಕಾದ್ರೆ simplify ಮಾಡಿ ನೋಡಿ, answer will be option A. So if you are not clear with the steps, you can ask. So Elaine, confusing part is, that is the integration part. If you don't know the integration, that's all confuse agate. Otherwise, question is simple. Okay, copy down. Okay, next question. Yes. So see here, for which of the following dependencies of drift velocity VD on electric field E is Ohm's law is obeyed? So in simple ಹೇಳ್ಬೇಕಂತಂದ್ರೆ, so which of the following is identifying or it is giving you the relation between drift velocity and the electric field? E is the electric field, VD is the drift velocity.
Option B.
Option?
B.
So here option A is the right answer. It is directly proportional. Okay. So when the Ohm's law is obeyed, here VD is directly proportional to E. So here you can see, as we know that the drift velocity. Okay. So nimgide equation gottiratte, the relation between current and the drift velocity. I is equal to NEA VD. So in this equation, if we write for VD is equal to drift velocity is equal to, that is I divided by NEA. Okay, so as we know that current by area, the current upon area is called as what? That is the current density. So therefore it is J divided by N into E, which is equal to VD. J upon NE, which is equal to VD. Now here J is equal to, so J is equal to, we know that that is conductivity into the electric field upon N into E, upon N into E, which is equal to our drift velocity. So for the given material, the value of conductivity, the number of electrons and the charge of the electron, everything is constant. Therefore, we can say that the drift velocity is directly proportional to the electric field. Next question. Yes. See here, a charged particle having drift velocity of 7.5 into 10 to the power of -4 meter per second in electric field of 3 into 10 raised to -10 volt per meter, the mobility is. So here you need to calculate the value of the mobility. They have given the value of the drift velocity and the electric field. So drift velocity, electric field, we need to calculate. Mobility is equal to. So very simple, direct question it is. That is the mobility is equal to drift velocity per unit electric field. Direct formula substitution.
Option B.
Option B, I think it is right. Yes, option B is right. So drift velocity by electric field, 7.5 upon 3, it will be 2.5 into 10 to the power of +6. Next question. Yes, so this you can work out. See, match the column 1 and with the column 2. So first column is given as Ohm's law is applicable to, Ohm's law is not applicable to, alloys have. Column 2, it is given as metals, greater resistivities, diodes, electrodes, semiconductors. So below you can see the options A, B, C, D. So ಯಾವ್ದು ಕಾಲಮ್ ಮ್ಯಾಚ್ ಆಗತ್ತೆ ಅಂತ ABCD ಅಲ್ಲಿ ಚೂಸ್ ಮಾಡ್ಬೋದು.
Option B, ma'am.
Option B, A is equal to P. Ohm's law is applicable to metals. That is right. That is, Ohm's law is not applicable to diodes, electrolytes, and the semiconductors. Alloys have the greater resistivity. Yes, option B is right option. Next question. The IV characteristics shown in the figure represents. So here, whatever the graph you are observing in the figure, that is current versus voltage. So whatever the graph is there, it is for which device? Whether it is for ohmic conductors, non-ohmic conductors, insulators, superconductors.
Insulators.
Which one?
Option C, ma'am.
Insulators. It is option B, that is for the non-ohmic conductors. Okay, the given IV characteristics of non-ohmic, or you can also say that non-linear conductors. It will be a curve. Okay, so if it is ohmic, then it will be a straight line passing through the origin. So insulator gatara baralla. Okay, then next superconductors, that is different case only. Next, which of the following is correct for VI graph? A good conductor.
Option A, ma'am.
A or C?
A, ma'am.
Yes, for a good conductor, the graph between voltage and current does not obey exactly Ohm's law. It shows some deviations from straight line. It shows some deviation from the straight line. Okay. Next. So this one you leave. It is not that important. This one. The resistivity of alloy magnine is, so if you do the experiment potentiometer or meter bridge, there whatever the wires you are observing, those wires are made up of the alloy called as magnine. Okay, so here the resistivity of alloy magnine is, so resistivity, hope so you know what you mean by resistance, resistivity. Okay, so see, alloy idu magnine alloy idu resistivity ಏನಿರುತ್ತೆ ಅಂತ, nearly independent of temperature, increases rapidly with increase in temperature, decreases with increase in the temperature, increases rapidly with the decrease in temperature. For alloy, the resistivity, that is option A, it is nearly independent of temperature. Okay, so it is not depending on the temperature. Resistivity, remember, it is for the resistivity. Next question. So this is based on the coefficient of resistivity concept. That is, the resistance of a heating element is 99 ohm. So resistance value is given as 99 ohm at room temperature. Okay, so this is at the RT value. RT means the resistance at room temperature is given as 99 ohm. What is the temperature of the element if the resistance is found to be 116 ohm and the temperature coefficient of the material is given as 1.7 into 10 to the power of -4 per degree Celsius? You need to calculate the temperature at which the resistance becomes 116 ohm. Okay, so simplification will be little lengthy, but very simple concept, direct formula based, but calculation is little lengthy. Here you can see, that is, we know that, so illi resistance anta kottidare. Sometimes the same question will be in the form of resistivity. That time the formula can also be written as the rho T, that is resistivity at temperature T and at 0 degree Celsius, inside the bracket 1 plus alpha into bracket T minus T0 bracket complete. So here first term is the resistivity at given temperature. Rho naught will be the temperature at the room, means it is at the room temperature. T is room given temperature, our own, this is written for the room temperature. Alpha will be a constant. This is called as the coefficient of resistivity. Okay, id bandaga resistivity agate. T again the temperature given, T naught will be the room temperature. So kottiro question alli we have it for the resistance. So adkoskara the formula will be RT is equal to R naught into bracket. It is 1 plus alpha into bracket T minus T naught. So same formula resistivity ge just rho anta modify madidre aitu. Okay. So they are asking you at what temperature the resistance is becoming 116 ohm. So therefore you have to calculate the value of T. So T is unknown here. So first you can simplify the formula. Andre enagatte steps will be easy to do it. So here what we can do, this one RT R naught and transfer madidre, it will be R divided by R naught, which is equal to, this is 1 plus alpha into bracket T minus T naught. Okay. Further simplification will be RT by R naught minus 1 is equal to alpha into bracket T minus T naught. So here if you simplify this one, it will be RT minus, because LCM tagondre enagate RT minus R naught by R naught, which is equal to alpha into bracket T minus T naught. Yes, so we require only T. Hagadre alpha kuda transfer madana. This will be RT minus R naught. Alpha will come in the denominator, that is alpha into R naught is equal to T minus T naught. So you can do this much simplification. Lastly T naught and transfer madkondre andre just addition madidre aitu. If you want, you can copy down this method. Steps you can copy down. So simplification is also given there. You can see all the values are there. Just substitute madbekaste. Main is this formula simplification. If you do mistake in that, your answer will be wrong. So RT is given, that is 116, minus R naught is given 99. Alpha is also given in the question as 1.7 into 10 raised to minus 4. So write down the steps. In answer baratte plus T naught you can do. Plus T naught will be 27 degrees Celsius, which is also given in the question. So T minus T naught will be 1010.10 degrees Celsius. Plus 27 means it will be 1037.1 degrees Celsius. That will be option D. So simplification, already I told you, simplification only the complication here. So many times based on this formula in board exam also question will come, as well as in the CET. Okay. So if any doubt is there, you can ask. Otherwise, we will go to the next question. Copied?
Yes, ma'am.
Yes. So similar one. The resistance of the wire in the platinum resistance thermometer at ice point is. So at ice point means it will be a melting point. Okay. At ice point is 5 ohm, and at steam point, so at steam point will be, it is 100 degrees Celsius, is 5.25 ohm. It is a platinum resistance thermometer. So they have not given it as water. Sorry, it is not 0 and 100. Okay. So suppose if it is specified as water something, then it will be 0 and 100 degrees Celsius. Different substance, ice point and steam point will be different. So here at ice point, the resistance is 5 ohm, and at steam point, the resistance is 5.25 ohm. When the thermometer is inserted in an unknown hot bath, its resistance is found to be 5.5 ohm. The temperature of the hot bath is. So what is the temperature of the hot bath? Again, you need to calculate the temperature. So almost the same method. See. So same formula. Again, in this question also, the temperature at T is given as 5.5. Okay, so here this is also same. R100 only, steam point, and this one they have taken it as same. This is 5 ohm, this is 5.25 ohm. Same formula, alpha is equal to, so if you want this formula simplification, see. RT is equal to, we have R naught into bracket 1 plus alpha T. So here if we substitute it for alpha, RT minus R naught is equal to 1 plus alpha T. So we want it only for alpha. Okay, so if suppose if I multiply this one inside the bracket, then it will be a proper simplification. So we have RT is equal to R naught into bracket 1 plus alpha T. This one is in the, this one. So alpha we require and T will come in the denominator. Otherwise, R naught, any other method, RT is equal to R naught plus R naught alpha T. So RT minus R naught. This one is better. Yes. So go with this simplification. Otherwise, it will not give you right answer. That is RT is equal to R naught into bracket 1 plus alpha T. So this R naught you multiply to the bracket. R naught into 1 is R naught plus R naught into alpha T. So this is RT. RT minus R naught is equal to R naught alpha into T. We want only alpha. Therefore, RT minus R naught upon R naught into T. So again, all the values are given in the question, substitution and simplification. So here how they have simplified C students. So alpha is equal to, we will get this one, right? So this is alpha is equal to RT means how much? It is the give steam temperature minus R naught means the ice point upon R naught into T value is 100. That is the steam point, which is equal to alpha. So this one they have named it as equation 1. Next, what they have done, that is let the temperature of the hot bath is considered as T degrees Celsius, which we need to calculate. So therefore, now the simplification will be alpha is equal to RT minus R naught upon R naught into T. Here we are not substituting T, okay? This T is only unknown. This is our equation 2. So equating equation 1 and 2 and simplification you have to do. So you can see how to do this one. Equation 1 is how much? That is R of 100 minus R naught by R naught into 100 is equal to, equation 2 is what? That is RT minus R naught upon R naught into T. So T is unknown here, remaining all values are known. Okay. So after equating equation 1 and 2, see, this R naught will get cancelled on both the sides. So we will have R of 100 minus R naught is equal to RT minus R naught divided by T. So we want only T. So T and transfer madkoli. Therefore, it will be T is equal to RT minus R naught upon R of 100 minus R naught. So RT is 5.5, R naught is 5 ohm, R of 100 is 5.25. So all the values are given in the question. If any doubt is there here, you can ask. So ಇಲ್ಲಿ ಎರಡು ಬರುತ್ತೆ. Okay, so question ನೀವು ನೋಡಿದ್ರೆ ಮತ್ತೊಂದ್ಸಲಿ clear ಆಗುತ್ತೆ ನೋಡಿ. I'll display the question. See, the resistance of the wire in the platinum resistance thermometer at ice point is means R naught it is. At ice point means that is R naught value. And that is given as 5 ohm. And at the steam point means it is R of 100 is 5.25 ohm. When the thermometer is inserted, so this thermometer, when it is inserted in the hot bath, its resistance, so its resistance at that temperature will be 5.5 ohm. ಹಾಗಾದ್ರೆ ಇದೇನ್ hot bath ಇದೆ, what is the temperature of that? This T you have to calculate. Okay, yes, is it clear now? So accordingly we have taken equation 1, equation 2, and we are simplifying that. See the steps. If any doubt is there in any of the step, you can ask. So equation 1, this is not that one. One second, just where it is, this one. So you can see equation 1, equation 2, equating equation 1 and 2, and substituting all the values, the answer will be 200 degrees Celsius. Check if any doubt is there here, you can ask. So current electricity will be little tough. Okay, moving towards the next question. So see the next question. So this you can write. The resistance of a wire in a heater at a temperature is 65 ohm. When the heater is connected to a 220 volt supply, the current settles after a few seconds to 2.8 ampere. Means current is there, voltage is there, resistance. All the three quantities are given. What is the steady temperature of the wire? Means again you have to calculate T value. Alpha value is given. So the resistance of the wire in a heater at room temperature means R0 is 65 ohm. When the heater is connected to 220 volt supply, the current settles after few seconds to 2.8 ampere. So here R0 is given, RT calculate ಮಾಡ್ಕೊಳ್ಳಿ. RT calculate ಮಾಡಿ using voltage and current value. Calculate RT means the resistance at the T temperature using voltage and the current. So once you calculate that, nimge RT baratte, you have RT, R0 value, alpha is also given. So RT you can check it out by using Ohm's law, that is V by I. Once you get the RT, you can calculate RT is equal to R0 into bracket 1 plus alpha T, and you can simplify it for only T. That's it. So these type of questions are little time consuming because of the simplification method. Simplification so jasti agatte aste. So here you can see, if you want cross verify the answer, your resistance must be 78.6 ohms. Your resistance must be 78.6 ohm. Temperature is given. So R2 into bracket R1 plus R1 into bracket L1 plus alpha T2 minus T1. T2 you calculate, T1 is 27. Your answer should be option D, 1258 degrees Celsius. Where you are going wrong, you can check here. You can cross verify your steps. Very, very important, students, this formula. Because ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ಎಲ್ಲಾ values ಗೊತ್ತಿರುತ್ತೆ, but steps mistake ಆಗೋ chances ಜಾಸ್ತಿ ಇರುತ್ತೆ. Okay. Either division, multiplication. If you do little mistake also, answer will be wrong. In CET and all, at least you will understand where you are going wrong if you are not getting the options. But in theory paper, this is very difficult, see, because you will think whatever you have solved, that is right. But that is not the case here. See this. 1258 is the answer. Okay, next question. This you take it as homework. This one you copy down the question as homework. Again, similar type. So I'll not discuss the answer here. You do it as a homework. A wire has a resistance of 2.5 ohm at 28 degrees Celsius and a resistance of 2.9 ohm at 100 degrees Celsius. The temperature coefficient of resistivity means alpha you have to calculate here. R value is there, R not value is there. Alpha you have to calculate. Copy down the question. You can do it this one as homework. Okay, next. Okay, see this. An electric heater is connected to the voltage supply. After a few seconds, the current gets its steady value. Then its initial current will be. So see the question here. So you have the electric heater which is connected to the voltage supply. After a few seconds, what happens? The current gets its steady value. So when it gets the steady value, what happens to the initial value? Okay, equals to its steady current. Slightly higher than its steady current, slightly less than its steady current, or the initial value will be 0. So steady current means what? That is, it is nothing but the DC current that does not change its intensity. Okay. So that is called as the steady currents. So here option B is the right answer. So the steady slightly higher than its steady current. So initial value matte steady current ge difference irutte. So initial current will be more than the steady current value. Okay, when it is connected to the voltage supply. Next question. If voltage across a bulb rated as 220 volt 100 watt drops by 2.5% of its rated value, the percentage of the rated value by which the power would decrease is, here we need to calculate the value of the power. So voltage is given as 220 volt, power is given as 100 watt and it drops by 2.5%. The percentage of the rated value by which the power would decrease. See how to do this one. As we know that power is equal to, we have the three formulas. So remember all the three formulas. Power is equal to the product of PI. Power is equal to I square into R. Power is equal to V square by R. These are the three formulas we have for the power. So in this question, they have given for voltage and power. Erde kottidare avaru hoda. So question alli irodu idu erde value. So therefore I'll go with this one. So therefore power is equal to, it is V square upon R. So we cannot go with this because current is not there. This is also current is not there in the question. Hagagi now use madbekagirodu P is equal to V square by R. So as the resistance of the bulb is constant. So question alli resistance is constant. So therefore we can leave this term and we can consider it as the change in power to the initial power is equal to 2 delta V by V. ಇದು ಎಲ್ಲಿಂದ ಬಂತಂದ್ರೆ in first year we will study the relative error. If you remember, we study the relative error. The relative error is given as, so the suppose x is a given value, delta x is the error in that. The relative error is expressed as delta x by x. Okay, so one more is there. When it is a power, suppose if you have x square, the relative error is written as 2 into delta x by x. So in the first year, first topic, there we will study this. So allinda tagondidivi. The relative error delta p by p is equal to 2 into delta v by v. So here the percentage decrease in the power we need to calculate. So therefore delta p by p, as it is percentage decrease, multiplied by 100. So delta p by p is nothing but what it is, 2 into delta v by v into 100. So here delta v by v is given in the question. The voltage drops by anta helidare. The voltage drops by 2.5%. Therefore it is 2.5%. So 2 into 2.5 will be 5% is your answer. See if any doubt is there in any of the step, you can ask. So power, the decrease in the power, percentage decrease in the power we are calculating. Okay, next question. Yes, this question. In a potentiometer, a cell of EMF 1.5 volt gives a balanced point at 32 centimeter. Yes, if you have done the experiments, potentiometer, then you will understand. Otherwise, little it will be complicated. So in the potentiometer, what happens? We will have the two voltage or the batteries. So we will have E1 is equal to 1 voltage and E2 is equal to one more battery will be there. So for the first battery, so for the first cell, the EMF is given as 1.5 volt. So when it is 1.5 volt, the balancing length andre galvanometer will show the zero reading. So the balancing length when it is 1.5, it is 32 centimeters. So potentiometer mele 32 centimeter length ge you will get the balancing point. If the cell is replaced by another cell, then the balance point shifts. So balance point it is shifting to 65 centimeter. Hagadre, what is the value of this second cell? Okay, so this is direct, very direct question. Again, in the practical also we do this. So EMF E1 by E2 is equal to L1 by L2. So here E2 is unknown. You can just calculate what is the value of E2. L1 is there, L2 is there, E1 is there. Yes, what is the answer for E2? E1 into L2 by L1 will be your E2.
Option B.
Option B, let's see. Option A, see. E1 is equal to 1.5, L2 is equal to 65, L1 is 32, 3.05. Check whether there is a mistake in your calculation or this is wrong. So 65 by 32, if we do, it will be 2.03. 2.03 into 1.5 will be 3.04.
Yes, ma'am.
Yes, okay. Next question. In a potentiometer, the balancing with a cell at length of 220 centimeters. So again, the balancing length is given as 220 centimeter. On shutting the cell with a resistance of 3 ohm, balance length becomes 130 centimeter. Okay, so first the balancing length is 220 centimeter. When the resistance is 3 ohm, the balancing length is becoming 130 centimeter. So what is the value of the internal resistance? Small r value. Yes, as you people know, again, this will come in the theory as well as in the practical also. So the small r, that is indicating the resistance, is given by L1 minus L2 upon L2 into R. So all the values are there, just substitute it. You will get small r. L1 is 220, L2 is 130, and capital R is 3. Yes, option D. Okay, one more question. Here we need to calculate the capital RC. A potentiometer wire of length 100 centimeter has a resistance of 10 ohm. It is connected in series with a resistance and a cell of EMF 2 volt and of negligible internal resistance. Okay, small r you need to leave it. A source of EMF 10 millivolt is balanced against a length of 40 centimeter of the potentiometer wire. What is the value of the external resistance? See, question is, so here you have the potentiometer wire whose length is 100 centimeter. So when the length is 100 centimeter, the resistance is 10 ohm. It is connected to a resistance and a cell of EMF 2 volt, and internal resistance we need to neglect. Here the source EMF is how much? 10 millivolt, which balances against 40 centimeter. Hagadre, what is the value of the external resistance? See. So here you can see this. The current in the potentiometer wire is given as I is equal to V divided by R. So here, actually here the formula is like this. That is I is equal to V divided by E plus R. Okay, so this is the formula. V value is 2 volt upon EMF, battery source EMF is 10 millivolt plus R. This is I is equal to. Okay, so this is I is equal to. The potential difference across the potentiometer wire is, so V is equal to, that is I into R. Here I value from the above equation is how much? It is 2 divided by 10 plus R into R. So here into R value is given as 10. This is V is equal to. See, the length of the wire is given as 100 centimeter. Therefore, the potential gradient along the wire is, so the potential gradient along the wire is K is equal to, it is V by L. So V value is how much? It is 2 into 10 plus R divided by L. And here 10 is there. So therefore, here it will be 10 divided by 100. This is equation 2. You can copy down up to this point. Here, what is the asked in the question? what is the value of the external resistance? The potential gradient. You can copy down that till that. Balanced against so potential gradient is equal to mm, mm, this is right. Here actually in the question they have to specify the potential gradient value. It is given or what you check. Source of EMF 10 millivolt is balanced against the length of 40 centimeter of the potentiometer wire. What is the value of the external resistance? Here actually we require the potential gradient value here, students. So if we have the potential gradient value, then we can calculate here the R value. Here maybe some mistake is there in the question, because see here, but K is equal to, we have V by L. So here K value, suppose if they give R value, we can calculate. Otherwise, there is no chance. Okay, we will check with this question. So I'll see what is required in that. Okay, if any doubt is there in today's session, you can ask. Any questions, any specific question? No? Okay. So we will see, if possible, one more class we will do current electricity. Otherwise, first we will finish all the lessons. Again, later we can go through extra questions once we finish the entire syllabus. Okay. So till now we have completed the 3 topics. So next class we will be dealing with the moving charges.